I'd really looked at everything you could imagine to make this helicopter do what I wanted it to do at the price point that I wanted. I can hand on heart say that we couldn't have done anything else. We've done everything we can.
How do you personally balance the, I would say, impatience of wanting to get it done, but obviously having to do it right?
And so we're all really excited to see it come together. We're all very, very proud of what we've done. And we just want to see the fruits of our labour. This first gas generator test is basically a turbojet test. So it's like a 1950s raw jet engine. Hill helicopters will have shown that despite what everybody said, we could make a jet engine.
Jason, we're sat back here again, PC1. Hasn't been that long since we've been together, but lots has been going on. I just got a whirlwind tour of all the things that are happening around here. It's exciting to see. Thanks for taking time to be with me again.
You're very welcome. Welcome back.
Thank you. It's good to be back. Tonight I really want to focus in. Last our conversation was more broad about the whole program. This one I want to focus in on the GT50. Specifically, because there's so much to go over. There's so much discussion around it. I think there's a lot of misinformation probably about it as well. And so I wanted, well, why don't we start from the very beginning? Why don't we take it back again? For those that haven't sort of heard the genesis, the beginning of the story, can you walk us through again what was the turning point for you where you decided, I need to build my own engine, and why did you make that decision?
Okay, so I got this idea of what I wanted HX50 to be, this capable aircraft that was big enough and powerful enough to really do anything you wanted to do with it, to take your family and your bags and go places, and to be a really useful high performance kind of machine. I also wanted a level of refinement so you felt special when you flew it. And so I'd looked around at all of the engine options. I looked at Lycoming and Continental engines, and I couldn't quite get the power out of those to deliver the performance I wanted with a machine of this size. I looked at the other existing turbine engines, and we just couldn't get anywhere near the price point on those. They're great engines, lovely engines, but we just couldn't get anywhere near what we needed on price point. So we'd be carving up what little existing market there is, rather than, you know, bringing general aviation and light helicopters back to life again. And I'd looked at everything in between. I looked at old diesel technology from the dawn of the jet age, you know, naturally aspirated diesel engines. I'd looked at aeroizing big block American V8 engines. I'd looked at some of the quirky things that were being developed at the time that people weren't necessarily aware of. I'd really looked at everything you could imagine to make this helicopter do what I wanted it to do at the price point that I wanted, and nothing got close. There was always a compromise. You could either have a helicopter that sounded like a tractor and didn't have the performance or the refinement that you wanted, and just about squeaked in at the price point, or you could have a helicopter that got the refinement but was outrageously expensive to operate compared to what the market's prepared to pay.
Right.
And that really left me with no options. You could either make a prettier version of the helicopters that are out there at the moment, and they'd have still sold, would have still done well with those, but we'd have never made a significant enough difference to the operating cost or the purchase price to be able to grow general aviation and to make both the private side of it and the light commercial side of it healthy again. And that really meant that we only had one option. We had to get a hold of all of the major sources of cost in the aircraft, and none of those are bigger than the engine. So we had to make an engine, and then you're faced with a simple choice. Is it going to be reciprocating or turbine? Well, if you're going to make a high performance helicopter, you need a turbine engine. It's black and white. So it had to be a turbine. So it was then really, how do you set about making the simplest, cheapest gas turbine engine to the highest quality that you can to give you just enough performance and the life that you need to be able to make the platform and the economics work. So as I've said many times before, really, we were kind of pushed into this corner through lack of options.
Right, yeah. It brings up a few questions in my mind. A couple of them, first of all, How long have you actually been working on this engine? Like, this has been a process going on for quite a long time in the background. So how long would you say that there's been a team or part of a team at least working on this engine?
There's been effort and work going into the idea of, is it possible to make a low cost, simple turbine engine for probably 15 years now. But the real developmental effort started in around 2016.
So we're coming up on 10 years now.
2016. Yeah. And again, you've got to remember at that point, we were funding that very piecemeal, with very limited funds going in from my original engineering business. Yeah. And just developing the core ideas, the core manufacturing processes, the core architecture of the engine, trying to find a technical strategy that basically drew on all of the proven ideas, all of the greatest hits, if you like. You heard me say that a lot before. All the things that we know and trust to make these engines work well, and then find a way of bringing that all together into a single engine that would work nicely in our helicopter.
Yeah. So a 10-year culmination now coming together, and this is finally the last stage. It's like a marathon that you've been running, and now you're kind of in that last sprint of the marathon. So what, if you had to distill it down to words, what does this engine actually mean to you? What does the GT50 mean to you at the stage that we're at right now in final completion here as we get that thing fired up next year?
I think it'd be like hearing your firstborn child cry for the first time, to be quite honest. It's something that's been a major part of my life for 15 years. It's been something that, because it's such a departure from folklore on how you should develop aircraft, it's something that's attracted a lot of debate about whether we should or shouldn't have done it. When we've done it, it's something that's going to be enormously disruptive in the industry, because it'll be a huge financial reset for what people accept is an acceptable price point for these kinds of aircraft and engines and the services that go around them. So it'll be enormous for me personally, and for the company, and for everybody that's worked on it. You know, there's a lot of people here that have been working on this, and it's full of the DNA of a lot of brilliant minds and a lot of brilliant and dedicated people that have contributed to it. In particular, over the period, I would say, from 2018, 2019 through to now. So about the last 7 years has been a huge push of gradually increasing resources and people to get it to where it is now, where we're building the first one, you know. And it's the first gas turbine engine built in the UK in its entirety for a helicopter since 1980. Yeah. It's a very, very, very big deal.
Yeah, it is a big deal. When you think about the Hill Helicopters mission, so beauty, performance, simplicity, how does the GT50 fit nicely into that sort of motto or that mission?
The GT50 is the cornerstone of the whole thing. It's the enormous price delta that allows us to make the machine at a price point that people can afford to buy it and then operate it. It's the part of the machine that makes the aircraft a thoroughbred helicopter. It gives it the combination of the performance and the reliability and the refinement that makes helicopters cool again. It makes helicopters desirable. Yeah, it's the beating heart of not only the aircraft but the whole project. So GT50 is enormous. I can't overstate how important it is to us or to the aircraft.
Yeah, when you know, there's people out there that say, okay, well, you know, you're getting close, but the engine's still not running yet. What does that really mean? Like, if you were to put this into perspective of where we are today versus where you started, what's been completed in over that period of time, could you sort of paint us a picture of what that actually means, the magnitude of where we sit today in the stage that we're at?
I think,
and I guess maybe to finish the question, how hard it is really to create an engine from a clean slate of paper.
Yeah. So I think what people need to understand about designing one of these engines, what people need to understand about the GT50 program is it's not just about designing an engine. We couldn't just design the engine and then send it off to the great and good of the aerospace supply chain, have all our parts made by experts, and then they all arrive back at our assembly facility and we bolt it together and away we go. Because we'd end up with exactly the same problem that the other guys have got in terms of the cost to do that. So what we've had to do is, first of all, we've had to determine what this engine needs to be. Then we've had to work out how to design every single component. Then once you've got all the components, the cycle, the components, the basic elements of the turbo machinery, then you've got all of the hidden stuff that nobody knows about and nobody really understands, like the secondary air system, like the lubrication system, like the intricacies of the fuel system, like the control system, like all the other services, like engine mounting, spring bars and damper systems and rotor dynamics, all of these things where every single piece of that has to work properly, otherwise the engine doesn't work at all. You know, and every single one of those elements is complicated. The bar to entering this market is really, really high. And lots of people do little RC jet engines, and lots of people can, you know, attach a blowtorch to a turbocharger and say, look, I've made a jet engine. It's really not the same as when you're trying to make an aerospace grade engine that has got to be faultless for 5,000 hours between its overhauls. And so it's what we've been doing over this period is developing the ability to, well, defining what the engine needed to be, developing the ability to design every one of those components, then designing every one of those components, then doing all of the systems that go around the engine. And then on top of that, once you've defined what you want the engine to be and what all these components look like, then because there isn't a supply chain we can go to that we can afford, we've then had to develop all of the processes that you need to be able to make every one of those components. And you've heard in numerous videos that we've done throughout the course of the program where we've been trying to demonstrate what we're doing. Many of these components have got 30 stages to make them. Right. You know, you've got plating and heat treatment and machining and grinding and casting, and then all the quality controls, and then all the inspections, and it just goes on and on and on and on. And at first, you are using specialists out there in the supply chain to go backwards and forwards, and so you drop it into the queue for each one of those steps along the road to get a component done. And for each one of those, it's a new product introduction program for them. So there's learning for them on our parts. And so the apparent simplicity of a jet engine totally belies the level of engineering complexity and the sheer amount of work that's had to go in behind the scenes to get us to this point. But I can hand on heart now say that we're there with that, and the gas generator part of the engine's going through the shop at the moment. The power turbine won't be far behind it. You've seen the drivetrain and the starter gen on the test bench already. And yes, it's a big job, and yes, it's taken a bit longer than we hoped it would. But many of these things, you don't know the problems you're going to have to solve until you get there and you've designed yourself into a corner, and then you've got to work out how to solve it, you know? So that we've done all of those things now, and we're about to crest the hill when these things will come together and this engine will splutter into life for the first time. And again, just to manage expectations, don't expect it to work perfectly, because it won't. You know, it'll be nursed through the testing program until we've got it set up just right, and then we'll be able to go into the endurance program and start to prove its reliability and its credibility before it gets to go flying.
Yeah, it's definitely a fine-tuning process. Can you give me some specific examples of challenges that you've gone through, either very recent or over the last while of the program, things that make you stop and say, man, this is really hard. I know we can get through it. I know we're going to actually complete this, but this is really hard.
I think in many areas of engineering, because there's such huge competition, and because a lot of the stuff has been so widely done by so many people. There's lots of knowledge out there, and there's lots of people with experience. I think the challenge with the really specialist stuff, like gas turbines and like certain elements of aircraft design, is it gets done so infrequently that often many of the people that know how to do it sort of retire and then die off without ever having passed on their knowledge. So there's a lot of lost knowledge in older guys that are no longer working, that you really need to be able to do this. So trying to piece that knowledge back together to be able to recreate some of these things like combustion systems and fuel spray nozzles and casting turbine blades and making bearings and squeeze film dampers and balancing axial loads on your rotor shafts and things like that. All of these sorts of things rely on a lot of know-how and a lot of capability. So, and the other thing that's well, if we go from the front to the back of the engine, so fortunately the compressor is a relatively straightforward thing to make in this day and age. Once you know how to condition the material and how to heat treat it, the machining side of it is fairly straightforward with the kinds of kit that we've got here. But as you start to go up then into the casings, like the diffuser and the casings of the engine, to make the engine light enough, these are big floppy bits of thin-walled material. And so the lost art of fabricating precision fabrications in superalloys, the kind of quality of welding and things that you need to be able to make these things to the standard that you need, and brazing and all these sorts of processes, every single one of these things is a difficult thing to do, and we've had to go through and develop all of those things. When you look at the combustor, we've featured that loads over the last 18 months or so, and that's because think of what we've had to go through to make that. You start with a flat sheet of metal that you've got to cut up into strips, then roll into rings, then form the rings, then size the rings, then connect it, then weld it, then CNC or laser drill it, then heat treat it, and it goes on and on. And all of those processes need tools. They all need jigs. They all need fixtures, and the tolerances that you have to work to for all of these things are really, really tight. And so there's a lot of stuff like that. Casting turbine blades. I mean, we're at the simple end of it. There's been a bunch of really cool videos floating around recently, certainly in our community and beyond, looking at single crystal blades, the likes of which you get in the big airliners and big industrial engines. We're nowhere near that. We're at the opposite end of the spectrum, where we've got polycrystalline blades running a lot cooler, that are perfectly adequate for what we need. But these are really complicated alloys. They've got lots and lots of things in them that all have to be handled very carefully. So being able to make the waxes to the right tolerances and without distortion, being able to make the shell so that it can withstand the ferocious temperatures that you need to, but then still have good enough conductivity so you can get the heat out of the blades as they're solidifying and cooling down to get your grain size right. Learning how to do the heat treatment, dealing with the fact that everything's got to be done under vacuum, then knowing how to correct for the solidification shrinkage and distortion that you get with something really thin mounted on something really thick. Being able to then take those parts and you've seen our turbine blades, right? They look like this. So how do you hold something like that when you've got to grind the fir tree onto the bottom of it? So learning how to hold these things reliably so that you can grind and so that you can measure, so that when all of these things go into the disc and they go into the assembly, they're in the right place. So the tip clearances are right, and so that you can balance the rotors. Learning how to balance something that's spinning at 50,000 RPM with 100 components in it, right, is a really difficult thing to do really well. And you have to master all of those sorts of things as well. So while it's quite easy to stand on the outside and say, but you haven't got it running yet. But we've done 7 million different things along the way to get it there. And so there's just a lot goes into that. And at the moment, it's quite normal for people to want to beat us up about that reality, right? But the flip side of that is we've already done that work, and anybody that wants to come and compete with us once we've got the engine running is going to have to do exactly that. And I've been at it for 15 years. So to develop this from nothing is really, really, really difficult, and we've almost finished doing that now. And so what we're about to see is us cresting that mountain and then scampering down the other side.
Exactly. I mean, that perfectly segues into my next thought is, other aerospace and, companies out there doing this, but not many. So how rare is it for somebody like yourself to move into this space and make your own engine? This is a pretty big deal. There's not many out there doing it.
Yeah, I don't think it's really happened since the dawn of the age. I mean, there's a few people. There's another light helicopter company that's done it, but not quite to the scale and the level that we're doing at the moment. They've done a great job. There's a new company making recuperated turbines for general aviation that's some engineers that have come out of Safran, so that's a really interesting project and could be really good for the lighter end of general aviation. So it does happen, but it's once in a blue moon. And the thing that's really difficult about engines in the aviation market is you've got no market. Right? There isn't really a business case for going and retrofitting engines into other aircraft. And nobody makes a lot of aircraft, do they? Nobody does. Certainly not enough to bankroll the development of a new aircraft and then its type certification around the world. And then the long period of time you've got to be able to run your operation and your manufacturing operation prior to anybody sending you a purchase order and saying, send me a few hundred engines. And so it's a really, really difficult business to get into. So where I think we've been strategically quite wise is we've created the market for our own engine. So by having the helicopter that everybody wants and being able to create the demand, we've created enough demand to justify the development and to offset those development costs over a number of orders that we've already got. So we're in a fantastic position from that point of view. But it is prior to us and these other two cases, and I think there's another one in Australia actually that does experimental engines. But prior to that, I think you're really looking back at the origins of the big companies. You know, the Allison engines, the early Lycoming turbines, the early Turbomaker engines as well. You're back to that kind of level since anybody's done it.
Which is back in the 80s, right?
Earlier than that, so late 50s, 60s. When all
the
of
last
those
ones
aircraft
have sort of happened.
and then the most recent ones that are in the helicopters that are in the sector that we're interested in. It's really the last ones to enter that sector were the 80s. So it's been a very long time since anybody's done that, and it's a blessing and a curse, right? It's a blessing that we're able to step into a very stagnant market and it's there for the taking. But it's a curse in that all the people that know how to do it are long gone.
Yeah, exactly. How do you personally balance the, I would say, impatience of wanting to get it done, but obviously having to do it right? Is that a challenge?
No, that's not a challenge at all. It's reality. Because everything inside these engines is highly strung. Okay, so the materials are working about as hard as they could possibly work. Every tip clearance, every gap, every seal, every tiny little detail like that, if it's not right, you run a very strong risk that the engine won't work at all. So we have to be really methodical and really, really careful to make sure that we get everything to the point where we are totally convinced that we've done everything we can. And we've just got to build it and test it, because so many of these things you just wouldn't be able to do anything about it on the test bench. If you've got your thermomechanics wrong and you're opening and closing gaps everywhere, you can't fix that on the test bench. You know, if your secondary air system doesn't work at all, or your fuel nozzles don't work at all, or your combustor distorts and pulls itself apart in the engine because you got your thermomech wrong, it doesn't work at all, and you can't fix it on the bench. So you've really got to make sure that the design is sufficiently mature and sufficiently well validated that the stuff that happens on the bench is stuff that you can do about. So tuning your throat areas to getting your compressor and your turbine matched properly, working through the operating speed range, working through any acoustic resonances and tuning that you might want to do there, tuning temperature profiles with your injectors and all that stuff that you can do on the bench. If you have large scale problems, it's a tear up. You're back to the drawing board anyway. You might as well have not built it. So for me, given how far we've come and where we've got to, it's really important that I make the test program as trouble-free as it can be. And there'll be lots of trouble, don't get me wrong, but I can hand on heart say that we couldn't have done anything else. We've done everything we can, and we've got a bunch of really, really intelligent and experienced people. And engineers are very risk averse as it is anyway, so these are intelligent, experienced and risk averse that have been poring over every detail to make sure that we all believe we've done everything we can. Now we've got to build it and test it and start working through the next phase of the development.
Well, let's get into that. Who are the people behind the GT50? So there's a team of engineers that have been working on this. Can you give us a bit of an understanding of who these guys are, their backgrounds?
Yeah, so it's a wide and varied team in actual fact. As I say, you're balancing a very, very distressed engineering employment market at the moment, and for a long time people haven't been going into engineering, and a lot of the people that carry the knowledge are quite old now and either retired or very retired. And so the team is comprised of a wide mixture of people. We've got a bunch of people similar age to me that have spent the majority of their career in other gas turbine companies, both aerospace and industrial. We've got people that have worked on the latest generation of business jet engines for other manufacturers. We've got people that have worked on large industrial gas turbine engines, and then we've got people that designed the last range of helicopter turbine engines that were developed in the UK and Europe. And those guys bring all of the experience of that they've developed over the last, in some cases, 40 years of experience. The guy that designed the original combustor is the guy that appears in all the books, right? Okay. And he was 90 at the time, and we've got a bunch of guys like that. The guys that worked with me in the very early days were predominantly industrial gas turbine guys with a little bit of aerospace experience, and that helped us get the cost down. That helped us get the architecture right. And then we blend with these guys that have got all this experience, younger and more dynamic engineers that major on being really, really, really intelligent. So these are the guys that have got today's hands-on skills with today's analysis tools, today's CAD tools, today's manufacturing equipment, and we can take the experience that we gather from these older guys that aren't necessarily the guys that want to be there designing and analysing parts on CAD and FEA and CFD. And we fuse those two groups of people together. So it's quite an eclectic mix of people from many countries and many backgrounds from all sort of age demographics. And we've fused that together to build a team that's been able to pull this off and get us to where we are now.
Yeah, I mean, I've seen the dedication that's gone into this, the long hours, the intense focus, everything that has to go into it. What's the feeling like in the room right now around that engine team?
I'd say it's like exam week now, right? So their homework's about to be marked, I think, and everybody's excited. Everybody just wants to get it over the line and onto the test bench now. Yeah. And so we're all really excited to see it come together. We're all very, very proud of what we've done. Yeah. And we just want to see the fruits of our labour. But at the same time, there's a healthy amount of nervousness and apprehension about the huge plethora of tests that this thing is going to be subjected to now to see how well it performs and what's left to do to get it to exactly where we want it to be. So yeah, excited, apprehensive. It's like exam week nerves at the moment.
Can you think of any stories or a specific story that captures sort of the spirit of the team or the mood that's there right now? Feeling like this is a moment that's pretty historic at this point?
I don't think anybody's seeing it in those terms yet. Like I say, engineers are quite modest and risk averse people, so they're still looking at the next problem. They're looking at the remaining bits of the power turbine that we've got to get out into manufacturing, and they're looking at the test rig and the instrumentation and then the control system and all of those sorts of things. So they don't really think in those sorts of terms. But when I think of when we run the drivetrain rig and the starter gen rig, when those things run for the first time, it almost doesn't matter what time of day it is, the room will be full. Everybody will hear it start going, and everybody will be down in there looking over it, and it's like watching your kids at sports day. You know, it's lovely, and all the guys they're extremely proud of what they've done. They're extremely excited by what we're doing.
Yeah.
But obviously, being the guys that are in the weeds with the detail, they live and breathe the detail. So they're just looking at the next problem. They're just looking at the next thing that they've got to solve. And once we've got this thing to work, there's obviously a significant testing program in front of it, a significant amount of development, and their mind is very squarely on not just getting it to work for the first time, but getting it to the point that it works every time, you know, and it never fails. That's the goal that we're all working towards.
When I think about the skeptics that are out there, the if people, you know, saying, I wonder if they're going to get this engine running and if it's going to work, etc. What would you say to them as far as the caliber of the people that you have to get this across the line and change maybe the mindset from if this will happen to when it'll happen?
So these are a very, very special group of people. These people, I would say, are beyond world class. So there's engine companies around the world that are full of people that have some expertise, but they need that whole infrastructure of an enormous company and 50 years worth of process documentation written down for them to be able to function at all. Yeah. These amazing people have done it with none of that through raw intellect and determination and an innate ability to solve really complex problems and to calmly and methodically work through everything that you've got to do to make these things happen. These guys are as close to the original pioneers in terms of their mindset and their capability that you're ever going to get. But of course, they have the advantage of already knowing what the answer is, right? We already know what you've got to do to make this work because there's lots of other engines out there that work, that we've all got experience of seeing, operating and being around for many years. So we're not staring into the deep blue beyond trying to work out what the answer might be. We know what the answer is, we've just got to do the work. So these people are amazing, they're bold, they're courageous, they're enormously capable, and they're just systematically working through the tasks until they're all done. And when they're all done, the engine will run, and then we put it in the helicopter, and then the helicopter will run. It's just physics, it can't fight back. If you do the right things, it can't fight back. So these are very special people.
Without giving anything this proprietary away, what would be the next key milestones now between now and engine running?
So at the moment, a lot of the focus has been getting the gas generator down into manufacturing. A lot of the components that go into the heart, the core of the engine, are extremely difficult to make. And we're not making production versions of the components, we're making development versions of the components at the moment. So these are things where they've sprouted lots of extra bosses and brackets and holes so we can feed instrumentation. I think there's 150 sensors in the gas generator alone. So all the wiring, all the pipes, all of the control systems to be able to study every aspect of the engine. So getting all of that together has been the main focus for the last month or so. We're then having a similar push on the power turbine, and then the main focus after that will be trying to accelerate the development of the test rig itself. So this is the infrastructure that provides all of the life support for the engine. So we'll be testing the core engine, so all of the key turbo machinery bits, but we have it on life support to start with. So it's got an offline fuel pump, it's got an offline lubrication pump, it's got all of its instrumentation, its control system offline. And that's so that we can control and vary everything we want to until we've got the engine set up just right. And once we've got that mapped out, then it can have its on engine accessories on and run completely under its own steam with its own brain.
Right.
And so obviously building the thing that tests the thing is almost as complicated as the thing itself. So we've got to build a test rig that protects the engineers, deals with all of the noise. I think when I spoke to you last time, I mentioned that this first gas generator test is basically a turbojet test.
Yeah.
So it's like a 1950s raw jet engine. And so dealing with the noise and the safety issues around that jet plume is really important. So developing that test infrastructure is the next big one. Okay. And then it'll be the commissioning of all of that, getting the first engine built and put together. There is something that's going on probably within the next couple of weeks actually, where the very first GT50 rotor is going together, and then we've got to go and prove out the balancing. So obviously we've got to get this thing running sweet as a nut, so that's got to go off and be balanced and make sure that we can have that running smoothly irrespective of what speed it operates at. So balancing, test rigs, and a big push on the remaining elements of the power turbine.
And how will you validate that first run? So like what would success look like for you for saying, okay, the engine is finally run now?
It's very modest things to start with. So the way the test program will propagate in broad terms, this isn't a full description of it, is we start by getting the engine together, getting it on the rig, making sure all the sensing systems work, making sure we haven't got any leaks, the lube system works, the fuel system works. Then we'll dry crank it. Yeah. So we'll spin it, make sure we haven't got any rubs, make sure we haven't got any rotor dynamic problems. And then the next milestone, the first exciting point, of course, is getting it to ignite. So combustion is a really complicated area, and so the first thing is to get the thing to ignite. Then your next milestone is to get it to self-sustain without the starter running, and then we'll perform a series of different fixed speed runs. So we'll run it through its speed range. During that period, we'll be getting the compressor and the turbine tuned properly, so setting or tuning the throat area on the first stage nozzle guide vanes, looking at the secondary air system and making sure all the cavities are at the right temperatures and pressures. We're keeping the oil where it's meant to be, and that we're not developing any rubs on any of the braidables or any of the labyrinth seals while we're doing all of that. So get that running, then we can start looking at acceleration and deceleration schedules and mapping out how fast we can speed the engine up and slow it down again, and then it'll develop on from there. So it'll be tiny steps, little step at a time. Yeah. But the first one I would say is get it to light and get it to make a jet engine noise, right? That'll be a big moment for all of us, and then it's back into the sort of disciplined process of working through the engine's operating points and making sure every little system works, every little part's at the right temperature and spinning at the right speed, and nothing's screaming, nothing's unhappy, and then we can build the systems up one by one like that.
Okay. You've said before in the past that belief is part of innovation. For you, what does belief look like or feel like at this point?
I think it's just it's an underlying confidence that I know we can do this. There's no doubt in my mind at all that we can do this, and that's not based on sort of irrational or zealous over confidence or anything like that. It's based on, coming up for 3 decades in engineering, dealing with the most difficult problems you could ever wish to come across as a day job. Yeah. And all we're doing is treading a well-trodden path for how to develop these engines, using people that have trodden that path many times before. And the only thing that's a bit unusual about what we're doing is the fact that we've made all the bits, and so we've had to go up that learning curve as we've gone. So for me, belief is about trusting the team of brilliant people that we've got here, being all over every little detail about what we're doing to make sure that nothing slips through the net, or at least nothing slips through the net to the best of my knowledge or ability. And then knowing that the laws of physics are fixed, and I keep saying this. The Brayton cycle is the Brayton cycle. The materials have known mechanical properties, known thermal limits, and if you do all the things that the physics says you need to do to make this engine run, and then if you do it in a way that others have succeeded before us, then there's no reason why it won't work, right? And there'll be lots of niggly little problems as we go, but that's what the business of engineering is, right? It's solving problems until the thing works.
Yeah.
And so we're just going to systematically work through it until we've done all of that. And when we've done all of that, we'll have the first sort of helicopter company developed gas turbine engine ever.
Yeah.
And that's when everything changes.
On a broader scale, the people that are out there watching that engine running for the first time, what do you want them to feel? How should they look at this as a milestone in aviation, I think?
I hope with the stuff that we've tried to articulate, with the stuff we've put out over the years, that they'll understand how much of a profound and significant undertaking it is. But I think because we're not selling the engine on its own, because we're not saying, here's a jet engine for less than a Lycoming, it won't immediately seem to have that much impact to people that are just looking from the sidelines. The real impact is that it completely underpins everything commercially about HX50. So it underpins the purchase price, it underpins the ongoing operating costs, and so everything that we've said about GA 2.0 and what that means for private owners and what it means for commercial owners is underpinned by that moment that engine runs for the first time, because Hill Helicopters will have shown that despite what everybody said, we can make a jet engine. And the moment you can make a jet engine that's affordable, the whole world changes for general aviation, because it means we can design sophisticated, high performance, cool and inexpensive aircraft that are of 2025. They're totally next generation compared to what people are operating today. And that's the impact that engine running will have. And that's what I hope people can see and believe in when it happens. And we're under no illusions, and I don't want anybody out there to be under any illusions that it running for the first time is just the start, right? We've got a load of work to do after that. Yeah. But at that point, everything that I've said is true, right? Yeah. We've made a jet engine. We've made it to, I already know we can make it to the price because we're building the bits now, right? So I know we can do that. Yeah. So now it's just a question of when it runs, I've proven that we can do it. Yeah. And then we've just got to knock all the little dominoes over until we've got it to the point that I'm satisfied it's good enough to go in a helicopter and good enough to be sold to a customer.
Yeah. Jason, thank you. Thank you for not only the time that you take with me to explain these things and go over all this, but I think speaking from somebody who has run a helicopter flight school for over 15 years, understands the struggle of the razor thin margins that we operate in this industry, the challenges, the supply chain challenges that we go through on a daily basis. What you're doing is transformative for so many different reasons. And I think the lives of the people, not just the private operators that you're making this helicopter for, but the commercial operators that are dealing with this on a daily basis, looking at their balance sheets and saying, okay, are we going to be able to make this work this month? It's going to be transformative. And you are making general aviation cool again. You're building an incredible helicopter that's going to be luxurious and incredible to fly, but you're also making the business side of it possible again, to be able to have healthy margins again, to have a lucrative enough business that you can take something home for your family at the end of the year kind of thing. And I think that's going to be so transformative. I can see it already. And so I know how much work has gone into this. I know the blood, sweat, and tears, the team that labors over this for countless hours, but it's all worth it. And I just wanted to say thank you for that. So thanks for your time again.
Thank you very much.